Hi everybody. So today we're going to be focusing specifically on triangles and classifying triangles. So remember, triangles are polygons with three sides, but there's all different kinds of triangles, and we're going to be able to today classify them based on their side lengths. So go ahead and get your notebook out, title the page Classifying Triangles by Side. Okay, so there's three different kinds of triangles based on their side length. So what you do to determine which triangle it is of the three different kinds is you have to measure the side lengths and learn a little bit about the triangles, and then you can tell whether it's these three different ones. So the first one is called an equilateral triangle. And an equilateral triangle has three congruent sides. Remember what congruent means from our other lesson? Then you know that it means equal. So these triangles have three equal sides. Okay, so three congruent sides. We're going to draw a few examples of that. So, to the best of your ability, try to make all three sides equal. And usually you'll see, well, maybe not usually, but sometimes you'll see something like this going on. That line through each side shows that each of those sides are all the same length. If one was different, it would have two lines. Now that means these two are the same, and that one's different, and there's two lines. So it's just kind of a way of showing congruency. It shows all those sides are equal. And so if all of them have the same amount of lines on them, usually it'd be one, then that would be an equilateral triangle. Now, this is the only way to draw an equilateral triangle, except you can expand it bigger or turn it around. So you might see it upside down. Just because it's upside down does not mean each side is not the same length. So since each side is still the same length, it is an equilateral triangle. Equilateral triangles are regular triangles that we learned about in the last lesson. You can also maybe see it something like this. Doesn't matter its orientation. It also doesn't matter necessarily its size, but you all use the same size, but it could be big. As long as all the side lengths are the same, it's an equilateral triangle. All right. The next one is an isosceles triangle. An isosceles triangle is a triangle with two congruent sides. Okay, so some examples of these would be this one, that length is this long. You would need to measure maybe if it was close, but this one you can tell that one's shorter, and these two are longer. But to make sure they're the same, when you're doing equilateral, isosceles, and scaling, if you're trying to figure out between those, you use a ruler to measure the outside, right? So if I measure this with a ruler, that one's like 5 inches. That one's 8 inches, and that one's also 8 inches. And so then I would know, okay, these two are the same. So I put the same amount of lines on them. And since there's two side lengths that are congruent or the same, then it's an isosceles triangle. Isosceles triangles could also maybe look something like this. All right, this time, if I would measure that at 6 and that at 6, so those equal each other. But this one is at 10 inches. And so that one will be longer. And so again, we have these two that are congruent and one that's different. And that would be an isosceles triangle. Now, isosceles triangle definition has a little bit of debate. Some definitions say a triangle with exactly two congruent sides, which is what we have here. This is the definition that we would use. It would need exactly two, no more than two, no less than two. But some definitions say a triangle with at least two congruent sides. So if it had at least two congruent sides, then it could also have three congruent sides and be equilateral triangles would then also be isosceles triangles. But we will use the definition a triangle with two congruent sides or exactly two. So it would be ones that have two but not three. All right, so we'll draw one more. An isosceles triangle could maybe also look something like this. Okay, if we measure these, that one's at 4.5, that one's at 4.5 inches, and that one's at 6.5 inches. So these two are the same, and that one is longer, so it's an isosceles triangle. All right, as I said, the last one is scalene triangle. So if it doesn't have three congruent sides, it doesn't have two congruent sides, it must not have any congruent sides, and therefore, that's what this definition is. Scalene triangle is a triangle with no congruent sides. All right, so some examples of that might be something like this. If we were measuring this with a ruler, that one is 4 inches. This one is 7 inches, which is different than 4, and this one's still different at 9.5 inches. So that would be a scalene triangle because all the sides are different lengths. Other examples might be something like this. Right, this one's the shortest, and then this one, and then that one. So they might not always have these lines on there, so you might have to measure. But if they have the lines already on there, then you wouldn't need to measure because that would tell you that they're all different sides if they're all different amount of lines across the sides. And one more example is something like this. Right? So these are ways to classify triangles based on their side lengths. You would use a ruler, centimeters, maybe inches, depending on how big the triangles are, to measure the sides to tell what the side lengths are. And that is how you classify triangles based on sides. These are either isosceles, equilateral, or scalene.